V6 con 258 caballos, la más indomable de las Amarok.
TV, toda la tecnología agropecuaria en acción, mostrando las experiencias más exitosas y rentables de los productores de punta, promoviendo el aumento de la producción en forma sustentable, respaldando el cuidado del medio ambiente y los recursos naturales.
Hola. Bueno.
Good afternoon, everybody. Alejandro was not able to be here. He was the true organizer of this presentation. He has a health problem, so he was the organizer and he was the one who invited all of you. We are going to listen to Andrés Cuinque from Uruguay. He is an agronomist engineer. He works in Iña Cazuelas and he had his PhD in Nebraska. And he is well known in Uruguay and he has been working in soils. And he's going to tell us about what they think about carbon in Uruguay. Then Marta Alfaro, Chilean, she worked for Iña, Chile. She's also an agronomy engineer and she is researching New Zealand. And then Bruno Alves, who is going to open the floor. He is an agronomy engineer of Embrapa Agrobiology and well known of microorganisms in Brazil. The idea is for you to have presentations, then question and answer. We're going to have WhatsApp questions and the QR, and I understand that there are many people listening to you by streaming, and we're going to have a Q&A session after your presentations. So, Bruno, you have the floor.
Okay, gracias por la
Thank you for the introduction. I'm going to speak from the podium.
Sí, pero acá no muestra, pero creo que la batería sí fue. Ahí. Esa la subí. Gracias. Buenas tardes a todos.
Good afternoon. Thank you for the introduction. Before starting, I would like to thank APRESID staff for having invited me to participate in this event, and also for their support and for my trip from Brazil to Argentina. Regarding carbon, Brazilian overview, that is the objective of this presentation. The idea is to show two significant points for Brazil when we speak about carbon. The first one is soil fertility, and the second one is the current situation of the climate emergence that we are witnessing. That is my personal opinion, but I think that we are living very challenging times, and all mitigation effects of GHG are very important, and soils can contribute as a carbon reservoir. So to start, you can see that the Brazilian situation, we are comparing Brazilian, Chilean, Uruguay, and along the event we also have some Argentine visions regarding carbon. But Brazil is in a very special situation. Most of the territory is in the tropical region, and this is very hot, humid region, and we have very poor, very deep, infertile soils with a low organic matter content, and so the fertility as a consequence is very low. In green you can see the altisols, and here you can see that there are you have the latosols, oxysols, and in orange we have the altisols, and here you can see that there is a little difference, but in general all of them have the same fertility problem. And we are going to see that the organic matter, carbon in the soil, is key so as to improve this situation. Here, a photograph of Laudosol oxysol of Brazil in red is iron-rich with high aluminum saturation. And here you can see the dark layer associated with organic matter, and argisol and ultisol we can have very low, and here you can see the mollisols common in colder climate countries, and in Argentina you can see that they have a thicker layer of carbon. And here is the most important point of what I'm talking about, and that is the table of a chemical of cationic exchange, and here we can see the global capacity of cationic exchange of soils. It is very important because it gives an idea of the capacity of soils to store and retain water, and oxysols and altisols that have quite a similar cationic exchange attribute compared to mollisols. You can see that there are 4 or 5 less capable. This is a significant difference, and the concern should be the main point in Brazil in terms of sustainable production regarding soils. And this is to complete information. Here you can see data of latosols and oxysols in Brazil. Here you can see the significance of soil carbon for soil fertility. And while we increase the content of carbon in the soils, the exchange capacity will also increase in a linear way. So based on this study, there are other studies that are showing the same, but this was quite emphatic. In average, organic carbon will contribute 40 times more the cationic exchange capacity of the clay fraction of the soil. And here we have iron oxide and aluminum that will have an effect on the exchange. And matter is really very important for soil fertility. What happened with Brazil? Here you can see a portrait of what happened with the history of Brazil. It has 850 million hectares in Brazil, and before Cabral arrived at Brazil, was covered.
E o que ha pasado com o tempo
was covered by forest. Then you have the elimination of this area to have croplands and pastures and grazing areas. And in 1985, here we can see the map that we were able to get. We can have a picture of the vegetation coverage, 649 million hectares. And here, compared to 2021, we can see a change of 85 million hectares during this time. But considering the territory and the situation in 2021, in that year, we saw that the exploration of the territory started, and there was a reduction of 286 million hectares, and that underwent anthropic action, mainly because of crop production and pastures. And it calls the attention something here. Today in Brazil, we have about 156 million hectares of pasture, 65 million hectares from severe to moderate degradation. It means that throughout this time that we are using Brazilian soils, the management is not the best. Is not the best situation we are witnessing. And in the 70s and 80s, there was an expansion of production areas towards the center of Brazil. The production bases were conventional tillage. We adopted the models used in the northern hemisphere, and we just adopted that, which means that the situation in general resulted in carbon losses. And here you can see a map of soil carbon storage, and here we used IPCC methodology, and here you can see an estimate of total carbon stock for a layer of 30 to 40 centimeters. Here the recently prepared map by Embrapasol. Here you can see the carbon stock. We have a lot of uncertainty here, but clearly you can see that considering the initial stock and the final stock, there was a reduction of 2,000 billion carbon tons for the 30 centimeter layer. If we consider this quantity based on the area of cropland and pastures, 220 million hectares, there was an average reduction of approximately 10 carbon tons of hectare for the 25 to 30 layer. 25 to 30% reduction from the original carbon stock. So it is quite clear to everybody that the first problem is that carbon stock reduction in croplands results in loss of fertility or a reduction of productive potential for these soils. And there is another problem still. Here we have the challenge of reducing GHG. Brazil has 25 to 30% of total emissions related to agriculture. So here we are under international pressure. We have to do some changes so as to have a more productive and less detrimental results. And we use inputs. We have cattle, and we have methane, nitric oxide, and fossil fuels that are necessary for agricultural production. And Brazilian situation, when we compare the two maps I showed to you before, indicate that there is a high potential that depending on how we are managing the systems, we are going to be able to recover part of this carbon that we lost in our soils. So based on this, there are public policies in Brazil that are already, well, some of them are already in force. And since 2010, others are being deployed. But to understand the dynamic of the carbon stock in the soil, we can see this figure that gives us an idea of what is going on with the carbon stock. In general, when we have a system in balance like a forest, this system requires a balance, and here you can see photosynthesis that is going to fix carbon, which is similar to the quantity of carbon that is going to be mineralized and that is going to be emitted through the atmosphere. But if we have deforestation and an alteration, a change of the soil a situation that we're going to see is that there's going to be a disbalance between the input and output of carbon in general. There's going to be a drop of carbon stocks with time, but these systems reach a balance, and then we have situations which in general where the carbon stock is going to be below the carbon stock that was originally seen under the vegetation. So these are related to the maps I showed to you before. But when we manage these soils, we have the possibility of having carbon stock again in the soil. And here you can see A, B, and C showing that depending on the systems adopted, the carbon input might be increased. Once again, we reach the balance. So the first point that we think about crops. What is the basis of information in Brazil based on experiments where they compared soil carbon stocks, crop systems compared to the vegetation? We can consider that the soil is like a box. In general, we consider that this box under the forest and pastures will represent 100% of this region. Carbon can be stored. Now, when we change the use to crop systems, there is a drop of carbon stocks, and in general, when using conventional tillage, there are much more detrimental compared to no-till. And here there are some papers that show that there is an increase, and we don't know whether this is an increase or a less severe drop than traditional system. But this is what happens. What is really clear is we have two studies. This is very interesting, and that is conventional tillage depending on soil texture and the reduction of soil with time. Here you can see the same area that was visited during 5 years. Here we saw a drop in carbon stock, and here you can see that there is a decrease of 30% in clayish and sandy soils. So what is proposed that no tillage is adopted in the country. That is going to be a stimulus. It's going to be part of the governmental plan so as to increase soil carbon stock. I think that, well, what is very interesting is that this study, they compared of different publications comparing soil carbon stocks under tillage and no-till. And here, Miguel Taboada very well said that depending on production system, the use of direct tillage is not going to result in an improvement of soil carbon stock. But when rotations are used and they have vegetal species that produce more residues, and also they are going to input nitrogen to the system, the carbon stock difference between tillage and no-till, here the difference is favoring no-till. And this is very important. We have to consider that humus, the more stable organic matter, has a carbon-nitrogen ratio from 10 to 12. So if we want to accumulate carbon in the soil, nitrogen balance in the production system should be positive. Nitrogen input should be incentivized so that we have conditions to develop organic matter. Here you can see the direct tillage in Brazil. In 1890, the use of no-till was very little. And then it was used more and more in Brazil because there was an investigation to adapt these systems, not only the south of Brazil, but also in the central region of Brazil. So today we have about 33 million hectares with no-till. It shows a national effort to improve the situation. The question is, what is the quality of these systems? Are we using crop rotations, diversified crops, so as to have soil coverage maintained a long time? And here in the region of Cerrado, the straw, the fallow, here we can see that they have soybean and then the corn stubble is. So here we need to have ecosystems. And what happens with pasture systems in general, as well as in Argentina? I have seen Dr. Taboada's presentation. When pastures are introduced, ozone carbon stock is very high, similar to native vegetation, and sometimes even better. So there are many results in the literature of Brazil that are pointing out this situation, but depending on the management, pastures undergo a quick degradation because of nitrogen depletion. And here the productivity is very low, and here you can see a portrait of the situation in Brazil. And here you can see the current situation, the potential situation, and you can see the herd. The statistics really point this out. And Strasbourg et al. In 2014 brought about an evaluation that with the use of nitrogen as well as other nutrients, the situation of soil usage could be used, and pastures will result in a more productive soil. And with the same area, we would have twice as much of meat production, and with a much more productive pasture for carbon stock. So we saw that pastures and no-till, and if the management is good, carbon stock is going to be increased as well as productivity. So this is a win-win situation for farmers, for producers. It's going to be a win-win situation. They are going to have a better produce, and this is the current situation. Farmers, producers are really willing to change, and since they don't have resources to invest in their production systems so as to foster or boost productivity, the government has adopted some actions related to climate change, like the NDC of Brazil. They have set up some public policies to improve the situations, and they offer producers resources so that they adopt more productive resources. This is the ABC plan, which is to adapt and low carbon emission in agriculture. And they offer producers loans with low rates and with long periods of no payment that are going to improve the production system, and 15 million hectares with recovery of degraded pastures, 5 million hectares and integrated systems. So there are other questions such as, for example, no-till, in the crops to increase manure treatment, the use of bio inputs, and low-risk areas. Manure, no? This might improve productivity at a national level and decrease the threat of the deforestation. So these are actions that combine both things. Here, 2013 to 2018, 12.5 billion reales were invested in a total area of 6.6 million hectares in 24.5 thousand contracts. This is a plan that is stronger and stronger, and the current government is having more resources. The idea is to intensify agricultural production, and here you can see the potential of introducing soil carbon stock through the roots.
It has been shown by Diaz-Zorita in 1997. That was shown the annual period of annual crops. You can see the decrease in soil carbon. However, when pasture is taken into account, stock increases. The same happens in Brazil. The red line shows the crops. You can see the carbon stock decreasing, but when this is rotated with pasture, crop and pasture, there's an increase. Pasture is integrated into the system, and that at least helps to make carbon stock stable. This is the most widely adopted system to recover pasture. Many resources are invested in this, and the investment is not returned in the short term. However, when crops are integrated and crops are fertilized, then the harvest, and then the investment is replaced, and then pasture continues to be productive with the residual amounts of nutrients in soil. That is what we call integrated systems for crops and cattle. The images are really clear. You can see soybean growing on stubble, and that is impressive, the amount of organic matter in soil. That system was not integrated with cattle, but the stubble was used as a cover crop to cover the soil, so there was no cattle. Therefore, the residual matter is more significant, but it has been shown that integrating this with cattle has also a positive impact. This is a very efficient system. And this is an advancement which is integrating forestry into the system. Dr. Miguel Taboada mentioned during his talk that in an effort to improve productivity, the carbon input in soil emissions are not always neutralized, but in these systems, in the short term, for example, 20, 30 years, you can attain neutral cattle raising because emissions are compensated not only by the amount of soil carbon stock, but also carbon accumulated in the biomass. So the system also generates economic benefits for growers. To finish my presentations, you can see some recent policies, not only the ABC plan, but there are some other policies in place to foster carbon stock in soil. One is being discussed, but it's already structured, and it is the National Decarbonizing Cattle Program. It aims at obtaining a certification for the production system. This is verification, assessing carbon stock. This is nothing but if the grower is implementing practices which are well known, are recognized as being reducers of the emissions and which are positive for carbon stock in soil, they are certified and they become part of a specific market. For example, we have this low carbon meat, low carbon soybean, and also the Brazilian market of emissions reductions, which is being discussed. The goal here is to regulate markets, and there's a great expectations here for growers because emissions milestones will be, or thresholds will be set, and those who are below the thresholds are mitigating so they can negotiate their carbon credits with those who are with emissions above the thresholds. There is also a voluntary market. There are many companies with this initiative. They are coming closer to growers to measure their carbon stock, their production practices, but this is not still active. However, there's a lot that has been done. And to close my presentation, I wanted to say that in Brazil, related to the carbon stock in soil, it is a win-win system. Our soils need higher organic matter stock because of fertility, so there's no degradation. And at the same time, there's a situation which is induced by climate change, and that is the entrance of resources, the availability of resources for growers to improve their practices, to improve their soils. This is a very favorable and positive situation for growers, and not only growers get advantage of this benefit, but the whole humanity. Thank you for this opportunity, and thank you for your attention. I will be staying here for your questions. Thanks. Thank you, Bruno. Now I will give the floor to Marta. Good afternoon. Can you hear me? Can you hear me? Okay. Thank you very much. Good afternoon. I'd like to thank the organizers for the invitation. I want to be part of this conference. My conference has a different focus, so let's begin. I would like to start with a framework to talk about carbon sequestration and gas emissions. Expectations are high, as Miguel said, regarding agriculture, and cattle raising can be carbon neutral activities. What does it mean? It means that once we have a productive system, the only way to make it a carbon neutral activity, that is zero emissions, the only way is attained by reducing gas emissions for cattle, enteric fermentation, manure management, nitrogen fertilizers in the crop systems, the use of energy and other supplies, level 3, and the potential carbon loss related to mineralization of organic matter or rotation. The potential of capturing, of reducing emissions is related to when you favor the carbon sequestrations in soils or deposits in general. So we need to have a vision for the agricultural farm. We will see that for a particular cattle farm, they can obtain neutral carbon by itself. In Chile, by the end of the 90s, we started a program for recovery of sustainable degraded soils. This program was related to a national policy to recover degraded soils, those which had low levels of organic matter, high levels of toxicity because of aluminium, because in Chile the acid level is very high. And the first pillar was incorporating phosphated baseline, which is contrary to Argentina. In Chile, most soils are anti-soils, so they fix their phosphorus fixation. About 85% or 90% of phosphorus used as fertilizer is fixed. So this is a high cost. This means a high cost for producers. And soils had a high deficit from 1 to 20, where 20 was the ideal value. The level found was 2, 3, or 5, and the cost for the grower to attain the 20 level was really expensive. So this program was launched to foster phosphated fertilization to fix this deficiency. Also incorporating essential chemical elements to benefit nutrients in soil. In Chile, from north to south, there's a wide variation in terms of organic matter. 1% in the north, and then those which are under pasture, where the percentage is 35. The gradient is related to temperature, rainfalls, and that resulted into a natural fertility condition that was different from region to region. So, depending on the region, the program was meant to increase the nutrients in those soils where it was needed. Another pillar was setting or improving an unaffected canopy. It was the one most widely used under the program, and it aimed at setting permanent pastures, avoiding rotation pastures or degraded pastures, and by incorporating legumes to attain permanent pastures. The phosphorus application component was the one that was best received by growers in the south of Chile. Related to the other pillar was related to intervention, favoring the use of no tillage or minimum tillage to avoid soil rotation. Finally, removal of physical barriers, for example, trunk logs, which is something very frequently found in the south of Chile, in Patagonia, as a result of fires. There are logs or parts of trees which were burnt, and that's a barrier. So the program aimed at cleaning those obstacles so that enough lots which were large enough were possible for agricultural activities. The two first had a great impact, the two first pillars that I mentioned. Let's see why. As I said, productive conditions from the north to south in Chile changed dramatically, and the soil characteristics do the same. In the north, 1% of organic matter. Potential of carbon sequestration is very high versus those in the south with a high natural content of carbon. Therefore, they have a limited potential for sequestering carbon. Here I'm showing the different response from the north to the south, from Mendoza to Patagonia, regarding the pasture effect, the increase in carbon based on yield. The red line is the baseline, no intervention. What was the soil like in terms of carbon, and then the columns show after a 10-year period of this management practice, which implied applying phosphorus-based fertilizers, and permanent pasture. You can see the differences. You can see the highest values as compared to the baseline. The soils could capture carbon. Organic carbon content was increased. However, to the south, this increase was much more difficult because of a natural limiting factor in soil. The star symbol indicates that the difference was significant as compared to the baseline. In the south of the country, you can see a decrease in productivity. Different connotations. In a 10-year period, growers changed the way they managed. They changed their approach. They changed pasture, they broke the soil, they started planting because of the fertility improvement. So, for carbon sequestration, the same management practice should be kept for a longer period as compared to the decision making at each field level. The potential is very important. When we talk about carbon tons per hectare, the potential is very important. In those soils with a high organic matter content, we work in terms of the surface, the available surface. We do not consider the capture or sequestration potential, which is the usual parameter for these values. This is an example from England. This is a long-term experiment in Rhode Hudson. It has more than 50 years, and you can see the ratio of carbon quantity in soil, and you can see there's a maximum reached. But that maximum level did not just take 5 or 6 years. It depends on soils, but it has been reached over 50 years. That is the long term that we refer to. So the period of time is much longer than the ones we usually consider in agricultural practices. And this is very important in fields. Also, I wanted to highlight the need of the field-based overview vision. These fields are related to cattle raising, permanent pastures, and there are trees in the land, and also forests, artificial or native forests. This is a milk production farm, and if we consider just the milk farm activity, we can see 50% of emissions from this activity, which in general greenhouse effect gases, methanol, CO2, calcareous emissions, nitrogen emissions, 50% of them relate to enteric fermentation of the cattle. There's no much margin for optimization, but there's a baseline. 34% relates to what is found in the pasture, urine, feces. 80% of emissions have been described, so that's very difficult to mitigate. The other emissions related, for example, to the use of energy, organic matter, or level 3 for energy, as Miguel said, or nitrogen fertilizers in the south of Chile has a limited impact. However, if we consider it from an overall perspective, not only the milk production activity, the milk farm, you can see here the milk farms. This is the one I showed in the previous slide. Meat production, cereal production, and some other products are reflected in this graph. Above zero, there are emissions, which means positive greenhouse gas emissions. Below zero, removal or carbon captures. In the light green, you can see soil sequestration. That is what we mentioned related to the potential of carbon sequestration. Dark green relates to what we get with from trees, forests, also European hazels, and you can see that how important it is to consider the production activity as a whole, not only each activity separately. You can see this negative value. This is a carbon neutral field. They do not only have milk farms, but also forestry. Therefore, their annual capture rate is very important. You can see cereal fields. If you compare them against cattle raising, emissions are very low. But at the same time, the potential for sequestration is very low if there are no other activities to take into account. Fruit trees, production systems, if the fertilizers are used diligently, they are carbon neutral, at least in the south of Chile.
For carbon sequestration, the management should be explicit. It occurs naturally in soils because we are fortunate and we have a generous nature. But if we want to favor or increase carbon sequestration and turn it over as an asset, it should be sustained in the long run. So, in order to conclude, first of all, there is not a single solution, nor for farms in the same region or in different regions. It's always going to be different, and we have to develop a strategy for our own benefit, customized. And also, the ideal is to have an overview and to see what is going on, and there are going to be increases on emissions in the other items. And also, we have to have a long-term vision. When we decide to develop a management to generate carbon, we have to favor it in the long run. And also, the management for carbon sequestration should be explicit. We have to manage the productive system so that it has a significant impact. So it is very important to be able to foster private-public cooperation in this subject, because from the perspective of research, we can develop a strategy, but it's not going to be effective in a practical way. And so we're going to need collaboration from the private and public sectors. And also it is necessary to have local data. The realities are very different from country to country, and we have to contribute with local data for this end. Thank you very much.
Bueno, muchas gracias, Marta.
Thank you, Marta. Andrés, you have the floor. Gervasio, thank you very much. Also, thank you to the organizers. And I would like to congratulate you because it is outstanding, and also because of the subject you have chosen as a core theme in conference by APRESID. It is a real pleasure to be back, because I really remember many years ago, in the 90s, that conferences started being organized in Córdoba, and one of them, I was invited to participate in Villa Giardino, that is in the hills of Córdoba. So thank you very much for having organized this panel. Thank you, Alejandro, for having invited me to speak. So now I have to speak about Uruguay. And let's see what is the general context. Of course, we are the smallest country compared to Brazil in the north and Argentina in the west. And I'm going to speak about what has happened in the farming area in Uruguay. In Argentina, you speak about the core area, the nucleus, and we have the western area. I am here near Colonia city, and INEA has some facilities in the north of Montevideo and an experimental station devoted to fruit plants. Also, we have an experimental station in INEA 23, which is focused on rice crop. This is a very good area for rice crops, and also we have cattle raising here. And then we have two other stations in the north of the country, near Tacuarembó, in the north of the country, which is a forest area, and livestock, especially in the north of the country. And here in Salto, opposite to Concordia, Argentina, we have another experimental station, and it is devoted to citric plant growing. I'm going to tell you what has happened in farming. These are the two experimental stations, and here we have two long-term assays being carried out in these two stations, studying crop rotation and also pasture rotation. So I'm going to share some details regarding this experiment. And today we have the agro-environmental platform, which is a well-ordered and systematic arrangement of carrying out long-term tests that we carry out in these experimental stations as well as in other stations. Here you can see an old rotation experiment 60 years ago. I have participated in the latest part of this experiment, but the truth is that we have really taken full advantage of this because it offers very interesting contrasts, not only regarding organic carbon, but also physical properties, erosion, for instance, among other things. Unfortunately, because of lack of time, I have chosen not to include a chart, which I have become bored by presenting it in several presentations, and it shows the evolution of organic carbon based on the different treatments and the impact of continuous farming. And they have a very well marked drop from the start of the experiment, and really it has not started from a naive condition, but also it has undergone an erosion process because of the farming use of decades before starting this test. And then with pasture rotation, in fact, we have seen that there has been a very slow and gradual increase of soil organic matter, and this increase is also proportional to how much pasture occupies in rotation. So when we have a 50 and 50 rotation system, that is 3 years of pasture, 3 years of farming or crops, they were able to accomplish a higher increase compared to other systems in which the crop prevails when compared to pastures. So, in order to give you a historical overview of our farms and the landmarks regarding preservation. During the first 50 years of last century were continuous farming without fertilization. And of course there was no pasture rotation in place. Then, as of the 50s, they started fertilizing the soil with nitrogen and phosphorus. And In the 70s, they started using the rotation of crops and pastures, where pastures comprised a mixture of legumes and grasses. And this rotation obviously included fertilization as part of the productive system. So our test or our assay.
Aquí, el experimento de largo plazo.
The long-term test started a little before crop and pasture rotation became dominant in Uruguay. When I was still studying in the agronomy school and I was about to graduate, I think, as well as others, perceived that there was quite strange to have facilities where only agricultural was in place. They were family-owned farms, and where they have different plots of land with wires. There were windmills to pump water and to feed the tanks, as well as so. When the plots were with pasture, they have water for the cattle, and this was a relatively complex system. And in the farms there was cattle because they had pastures and crops, and so they had not only farming but also cattle raising. In the 90s, the no-till system was adopted, and the hip occurred in the year 2000 when there was the soybean boom. So continuous no-till farming was in place. It was just one crop, soybean, and in those days they brought seeding pools to Uruguay from Argentina, so there was an increase with no-till technology, and also with an abusive use of soybean because it was very profitable. After the year 2000, there was a reactivation of Soil Preservation Act that has been passed in 1991, but they just needed to enforce it, and so it was mandatory to have responsible use and management of the soil plants. And in fact, they were oriented towards the production by ensuring not to go in beyond a tolerable margin of estimated erosion. But this act and the implementation through the use plans had the objective to produce by ensuring soil erosion standards.
And the main pillars on which responsible plans and use plans are rotations, cover crops, and no-tillage. These pictures were taken around 2008. I can't be precise on the date, but it was a beautiful area, a highly productive area of our fields, and they showed us the soil conservation problems that we had, even though no tillage practices were implemented there. So, how are soils today based on their organic carbon content? I will share with you the findings that we obtained with a survey of 108 commercial facilities, where we compared the quality of those soils against baselines values. We sampled under the wire as the best spot to get the purest information, undisturbed. It was not a pristine situation, but under the wire, we can say that that condition is highly preserved, not as much disturbed as other areas. So we wanted to assess the organic carbon loss, as some other speakers mentioned. It is more or less the same gap of soil organic matter that was described today. This is the relative organic carbon loss found in commercial facilities, where we can see that there was just a minor fraction. There was no loss, but a small gain. These are negative values because we are considering the loss. The other cases are soil carbon loss cases. More than 50% of the facilities have a 20% of loss of organic carbon. We can compare this against some other plots that we measured and observed similarly in long-term assays. For example, the old rotations in Estanzuela, and another one which is in Iña 33, Iña 33, which was started on no-tillage conditions, natural field conditions. Where do we find the relative losses in those plots that we studied? You can see the red spots for the old rotations, Estanzuela. This organic carbon loss relates to the continuous planting or cropping for more than 50 years, and this one here relates to the 50-50 rotations during 50 years. The same relative loss here derives because of the grazing rotation, continuous agriculture, in 10 years in the Palo a Pique essay. Just a 10-year period for a grazing rotation and pasture in Palo a Pique shows this relative loss of 10% of organic carbon. I think this shows clearly what may have happened to those oils and which is the degradation level they are suffering. These are our findings. And to summarize, I'm sharing with you the findings from other papers, which are quite consistent with ours. 20% of organic carbon in soil by Moron et al. Is the one I was showing. Another colleague, Mazzilli et al., at the facility level, the CREA facilities, he studied the carbon balance, and he concluded that 50% of facilities have a negative balance of carbon. Another independent and standalone study by Beretta et al., published in 2019, based on samples, lab samples, sent by growers or advisors. I think that the sample size was 10,000 data items. They concluded there is a gradual decrease of organic carbon in soil. Finally, this paper, which was published shortly ago, I think that Gervasio is one of the authors, a different approach, but we can see that the relative difference between the current and baseline organic carbon is being analyzed, and it can be studied today based on satellite information. This graphic depiction of the country shows that 30% of organic carbon loss in average, with some variations associated to soil types, among other factors. My questions. Do these decreases in organic carbon affect the yield? How do they affect yield? Of course, carbon in soil is important. I don't want to increase emissions. I'd rather have a system that captures more and more carbon. But another question associated to organic carbon and considering both dimensions that can be seen when carbon is well managed in soil is soil properties are affected or not. And this is also based on the old rotations study. Valentina worked on this paper for her PhD in the United States, and she analyzed the yield for almost 60 years of information by correcting yield based on different factors, and she attained this ratio with organic carbon in soil. It is shown clearly that by implementing different treatments, we are below the threshold. We are at 1.2, below 2.4, so there are different mechanisms that enable us to get this, the loss that results in the loss of fertility because of the loss of organic carbon. Valentina also here in her thesis analyzed apparent density and macropores, and she shows the association between the decrease in organic matter related to the decrease in micropores and apparent density. Similarly, in Argentina, findings show the same related to organic matter and yield. Diaz-Zorita et al. Studied a sample in commercial facilities in the Pampas, and they found something which is not very frequently seen in the literature, which is organic matter can be used as a fertility indicator. For wheat in Argentina, this is a relevant paper. Which practices of no-tillage approach can be used, I see, with the potential to improve the soil? Well, people have already mentioned this. Earlier today, there was an excellent session with 3 speakers dealing with management practices. So I'm focusing on no-tillage practices with stable return, double crop or cover crops, pasture rotation to increase fallow and to increase carbon sequestration in situ, pastures rotations as a very important practice, and then improving agricultural practices by any means to attain high yields for all plots and facilities. Biomass or carbon, which was not which does not originate in the plots, for example, manure or some other remediation practices, of course, these are options, and that should be taken into account. I also wanted to talk about the dynamics of carbon sequestrations in no-tillage approaches. These are challenging processes, and I see that in Uruguay these are actual current conditions, and we need to take them into account. At least organic matter has a high vertical stratification in soil, which means that you can see a rapid increment on a thin layer, first 5 centimeters or fewer centimeters. In that layer, you can check high organic values, but below, the soil is not as rich as this in the practice. At the same time, organic carbon saturation process takes place. These mechanisms limit the humification rate and efficiency is reduced. The efficiency for transforming carbon of biomass into organic matter. This has been dealt with earlier today, very professionally. So, soil is quickly enriched in the superficial layer, and by saturation, efficiency is being reduced for the transformation into organic matter. So, it is difficult to have carbon penetrating lower layers. At the same time, root exudates and biomass are more efficient for this transformation than the shoot of the plant. And so this is where we can intervene and we can use the root and the shoot of the plant so as to produce enough quantities of carbon at the soil level so that we can improve the whole profile of the soil, not just for the first 5 centimeters. Question is, how can we increase organic carbon in soils in deeper layers? As has been discussed, pastures are the answer. Perennial pastures that can last 3 or 4 years are the solutions, because these pastures can set deep root systems, enriching the whole soil. To highlight what I said related to the rich organic carbon in the superficial layers, you can find tillage. You can see that the tillage values are in the lower part of the graph, below the 10 centimeters, even below 20 centimeters. You can see that with no tillage practice, there is no increase in the carbon content in soil, something that is attained in the superficial layers, in the first 5 centimeters. This is the final slide for today. I wanted to share with you my perspectives to talk about my vision for Uruguay, to share with you my insights for Uruguay. Public policies, well, we have half and half for the glass. Half of it is full, half empty. There's still the requirement of use and management plans which are oriented only for erosion control. So we are seeing this as an opportunity to expand these plans so that these are not designed only for erosion control, but also to tackle reasonable carbon balances in soil, reasonable or better balances, positive balances, or above certain meta objectives. Growers, those that I talk to or those who I know well, there's a shared concern for soil preservation. They are aware of the current challenge or problem, and also these there are some difficulties related to price, costs, ownership, so the optimal practice can't be always implemented. And within INEA, we have the long-term agro-environment platform so that studies and papers and research can continue to understand organic matter, the mechanisms at the level of soil, not only related to carbon dynamics, but also taking into account other processes. There are research groups, both for INEA and the University of the Republic, the Agro-Sciences University, which are working on the carbon dynamics. These academic institutions have projects with national teams and funds, international teams and funds, to continue learning and researching on this topic. This is the end of my presentation. Thank you very much.
Bueno, muchas gracias.
Thank you, Andrés. Thank you, Bruno, Marta. Yes, we are late. We just have 5 minutes. I was asked to share with you a summary of the presentations, but I will skip this so that we can tackle some of the questions. There is one question that has been asked several times, and you covered this topic, the maximum potential of carbon sequestration. Which are the markers, which are the strategies to know how far they are from their potential? Maps, references, equations, differential equations. Very briefly, 1 or 2 minutes, can you please, each of you, can you tell me what would you do if you have only one chance to generate a map or an indicator? What would you use? How would you estimate the maximum potential? Well, this is a difficult question to answer, because having a reference, as we have shown, Marta, Andrés, I've shown that myself and some other people in the conference, soil carbon stock for the same crop, well, limits can be changed, the scope can be changed from one place to another. What we do now, the carbon market methodology implies monitoring. So samples are taken and then you continue monitoring at certain intervals, like 3 or 4 years intervals for comparison, and then you can assess the soil potential. Okay, that could tell us if we are improving. But Marta, if you have to say, how far are you from the maximum? Well, measurements more than estimation. We have compared against soils below forests, or in any plots, there are some regions which are naive. So that is the baseline. For example, the soil under forests is our ideal goal. We know we will never get there. So in short words, those areas where there's no intervention, what Andrés said, under the wire, yes? Yes, we need to get a potential map, but we need to measure and we need to make adjustments based on texture so that the gap can be set and defined, the missing carbon, as compared to the best preserved area, as compared to what I have in my plot. Okay, carbon increases yield. Once we have carbon sequestration in soil, it has a direct impact on climate, on the weather. The CO2 is reduced. If everything is so positive, why is it so difficult for us to do this? We have discussed policies. Andrés, you mentioned the use and management plans, which is the main limiting factor for growers to improve this. Why is it so difficult to get carbon sequestration if it has so many benefits for growers? One of the main reasons, in my opinion, is that these are management measures, not supply-related measures. but they imply a change in the production system to such an extent that it becomes less attractive. The ownership is one of the real challenges. If a grower who is responsible wants to talk with the owner of the facility, and he says, okay, I propose we have a 3-year pasture, I have to make investments, but please reduce the rental cost for me. After 3 years, I will be able to pay more because the 3-year will improve my efficiency. And the owner of the field or the facility would say, oh, what a pity, I know someone who can pay today more than you. Ownership. So ownership for you is the main reason. Yes, I think that in Brazil the situation is the same. Policies, climate-related policies that are being implemented in Brazil. We have the low carbon agricultural plan. It has been in place for 10 years. We have the second edition. That's a strategy that can favor the grower, that can enable the grower to get a loan so that they can improve their productive capacity. I think that in Argentina the situation is quite the same. Government incentives are, or the rules, the carrot, that may be the punishment. Also market, yes, the market, the demand is asking for carbon sequestration. So we are on time to finish today. I really appreciate your coming here from abroad, and I look forward to seeing you very frequently here in Argentina. Thank you very much.
Producir, crecer, compartir. Es el accionar de AFA, Agricultores Federados Argentinos. Nuestra cooperativa. Es hora de revalorizar lo hecho y celebrar el camino recorrido. AFA, un mundo de 90 años. Hecho entre todos, todos los días.
Precision Planting comenzó con una visión de mejorar la agricultura, desarrollando productos innovadores que puedan mejorar el desempeño de tus equipos y al mismo tiempo el rendimiento de tus cultivos.